Hi 111. In this video we're going to talk about section 3.2, which is going to build on our work that we just did in the last section in 3.1 when we were constructing linear models. Right? So again, I have our digital textbook open here so that we can work through this section together. And we'll also be needing our graphing calculators for this section, so you might want to go ahead and get those out now as well. The reason for that is because in this section what we're going to do is think about how we can build still a linear model. We'd like to still build linear models, but instead of building them from sort of being told what the slope and the y-intercept should be, remember, because in the last section we learned that we could write a linear function, right, like this, okay, and we were able to model using that kind of linear function as long as we knew the slope and the y-intercept, right? And for example, we did like a cost function last time, right, where we knew fixed cost was b and this sort of cost per unit here was m, right? That was our slope. That was the example we did for an application, okay? But that's sort of building a model from what your book likes to call verbal descriptions, being told exactly what the m and the b need to be, okay? And you just directly plug them in and there you go, you poof, you have a linear model. Instead, what we can do is construct a linear model so that it represents some sort of data that we're given, right? We might not be able to exactly make it fit is the biggest issue that we're going to run in here, okay? But in this section, what we're going to do is try to make linear models from data. Okay, and we're going to make use of our graphing calculators to do this because it has some pretty interesting commands on it. So let's first of all sort of get in our minds what we mean by from data, right? Okay, so what does that mean? So remember that data is just sort of information that is gathered and tells us about the relationship between two things, right? Two quantities or to real life situations, right? Or to real life variables here, right? So your book shows us, again on page 136 right here, remember this is a page number up here, it shows us how we can collect data in something like this, like in a table, right? So in this example, they're saying that for a certain team, there was some sort of baseball percentage and a certain run scored or something like that. I know nothing about baseball, so I don't know what these things mean, but notice that what this says is that there's a relationship between these two quantities here, between on-base percentage and runs scored, right? So if there was information like this gathered, right, all of this information together creates these ordered pairs, right, where on-base percentage relates to runs scored, right? They could have changed the x and the y, so this was y and this was x. They just chose it that way, right? And so here we have these ordered pairs like this, right? Okay, and so what we could do is plot all of these ordered pairs in the xy plane and get an idea of what they would look like, right? Of course, we would have to plot them as x versus y, right? Because remember, that's independent and dependent, and x is usually considered our horizontal axis and y our vertical. Let's see what a picture would look like of plotting all of these ordered pairs in the xy plane. This is on the next page of your textbook, page 137. Right, this is on the next page. So this is here our x-axis is on-base percentage, just like from the table, and the y-axis is run scored. And here's all of those little dots plotted on the xy plane here, right? And again, here's a picture produced by a graphing calculator. I'll teach you how to do that in just a few moments. But notice that in general, doesn't it appear like the data sort of starts down here and then sort of moves up in this kind of a direction, right? And you can even see it better over here on the graphing calculator window, where it sort of starts low to the left and ends up to the right, yeah? And there's no sort of funny like swoopy motions of the data or anything. It sort of just goes lower left, upper right, yeah? And so maybe here it could be that if we were to try to sort of say in general what kind of relationship these variables of on-base percentage and run scored have, maybe we could say or hypothesize that they might have a linear relationship, right? Maybe those two variables are related in a linear way, because possibly this data sort of resembles the pattern of a line. Now I know they don't all sit on a line, right? Which is, like I said, the issue that we were going to have. So yeah, so maybe we can tell that these two variables here, on-base percentage and run scored, perhaps have a maybe a linear relationship here, because again, it looks like it sort of goes lower left to upper right. Okay, and we should be able to tell that just by looking at some data, whether we in fact hypothesize that we have a linear relationship or not. So if we continue on with this page of 137 right here and just sort of look down a little further on the page, we can sort of see exactly what I mean by that, right? If we look at these examples of some data, right, they haven't given us the points, they haven't given us the variables or what they mean or anything. If we just had a sequence of dots, right, that were graphed, we should be able to tell whether they represent maybe a linear relationship or a non-linear relationship, right? Something that doesn't look like a line. Okay, so notice in these first two right here that if we had a scatter plot, and that's what these are called when we make these graphs of data like this, right? These are called scatter plots like this, right? If we had a scatter plot and the data looked something like this, where the dots are sort of going lower left to upper right, and it kind of sort of looks straight like that, we would say that that's probably a linear relationship, right? And that's a linear one where the slope is positive, right? Alternative to that is where we have this sort of downward looking relationship here, but it still kind of looks like a line. It goes top left to lower right, still looks linear, but in this case the slope looks negative. Right? All the rest of the ones that are over here to this side now, they don't look like lines, right? Which means that we wouldn't guess that the relationship between the variables, the x and the y thing, we wouldn't guess that their relationship is linear because the data doesn't look like a line, right? This one looks sort of like an arch like that, so that's non-linear. And this one has some sort of up and down and up behavior to it. That doesn't look like a line, so that's non-linear. And this one also is a little bit tricky to see because you might think it looks like a line, but notice it has a bit of a curve to it, okay? And lines don't have curves, so we would also guess that one would be non-linear also. Right. Okay, so let's see exactly how we can construct this linear model when we have, in fact, some data, right? So, if we had some sort of data like this and we said, well, looks like it's a linear relationship, how could we construct a model which would represent what's going on here, right? Which would appropriately model the relationship between the two variables, right? Because that's what we're trying to do, is create a linear model that represents the relationship between the two variables, okay? So to do this, let's try an example. So I'm going to scoot over a couple of pages in our textbook here to page 141. And we're going to do this first example right here, which is on page 141. We're going to work with number 19. Okay, and let me get a new piece of paper. Okay. So what's always going to happen with these kinds of problems is that we're not going to be given a specific piece of information about the slope and the y-intercept and then we write an equation. It's always going to be where we have this sort of, here's a bunch of data, right? There's a relationship between one variable and another, here's some data we collected, and write a model, right? So we have to do a little bit of investigating here to try to figure out what the model is going to look like because we don't know the slope or the y-intercept to model the scatter plot, okay? So let's read the problem first. So it says a pediatrician wants to find a linear model. Okay, that part we can understand. A linear model, great. Slope and y-intercept, and then it's a function, understood. Okay, and this model is going to relate height to head circumference. Height to head circumference. Okay, H and C, right? And that's the data we're given here, see? So this pediatrician randomly selects 9 children from the practice, measures their height and head circumference, and they got the data below. Okay, so that's how they got the data. So let H represent the independent variable. Okay, so H is independent. The word independent usually means X for us, right? Okay, so that means we want H to be like our X. And then it says let C be the dependent variable. Okay, dependent variable, that's usually our Y, right? Okay, so that means C is going to be like our Y variable. Okay, so we're going to let our X is going to be H, and the y is going to be c. Right? So whenever we, oh, my pen is not working. Here we go. So whenever we start writing our equations here, we have to think about like our h is kind of like our x and our c is kind of like our y here, okay? So let's see, what are we supposed to do? Use a graphing utility to draw a scatter diagram. Okay, so we have to produce that scatter plot thing from this data. Okay, so now is when you get out your calculator. Here's mine. Okay, and I also have a handy handout that I'm going to be giving you in class on Tuesday, which looks like this, which is steps for we don't have to know what this word means for right now, but it helps us to create a scatter plot in step one, right? This will be eventually finding the curve of best fit, or what we'll call in a second the line of best fit, because it will be a linear relationship, okay? But let's first just sort of see how this is going to work. Okay, so step one is to create a scatter plot. Okay, so if we complete step one, following all these scary looking steps here, we'll have created a scatter plot in our calculator, and that will be handling the first part of this problem here, right? Drawing a scatter diagram. Okay, so let's take our data. So here's our data, right? Okay, and remember that we're considering h to be the independent variable, it's like our x, and y is going to be like our c here. C is going to be our dependent variable, okay? All right, so we have our calculator right here. There we go. And we have our handout. Here we go. So let's see if I can get all of this to fit on one screen here. This is going to be tricky. Okay, so here's our steps, right? And here's our data. Okay, so the first thing we're going to do is we're going to turn on our calculator. Y equals, it says turn off any equations. Well, I don't have anything in here, just clear it out, right? The second step says hit the stat key. Okay, so stat right there. I just hit the stat key. I'm not going to open up our key presses here because if you notice there's nowhere to put them, right? So just try to follow the steps here. Okay, I hit the stat key, and then it says select edit, right? So that's this, just hit enter. And it'll bring us up to these lists here, right? These are lists, list 1 and list 2. It says type in the x values and type in the y values into list 1 and list 2 respectively, right? That's what where our data goes here, right? So in list 1, we're going to put our x values. Remember, for us, x values are the height, h. Remember, x is h for us, okay? So let's put all of our values for h right in there. So 25.25, and I've got my first one. It's going to go here. I just hit enter to stick it in there, okay? And 25.75, enter. 25, enter. 27.75, and you just keep going, enter. 26.5, enter. 27, 26.75, 26.75, oops, and 27.5. And I do believe that's all of our data, right? Yes, that's all our data. Okay, so now I arrow over to go to list 2, and now I enter all of the y values, right? And for us that is c, that's our head circumference stuff. So enter 16.4, enter 16.9, enter 16.9, 17.6, 17.3, and be very careful about entering this data in, because if you do miss a decimal point, or you add an extra data point or something like that, an extra piece of information, an extra x or y value, your calculator is not going to like that, and it'll tell you it can't plot your scatter plot. Okay, so we've got all of our data entered now, right? Now in step 6 it says hit second stat plot. Okay, so above the y equals key you see this word stat plot. Okay, that's going to allow us to produce a scatter plot. So let's hit second stat plot. And now it says that we need to turn one of these plots on, right? So it says select one, plot 1. That's what I've got right here. Okay, when I hit enter, and I need to turn that thing on. So make sure it's on, and hit enter to highlight it to turn it on now. These are all of the options here about what kinds of plots we could have. Notice that the scatter plot kind with the dots is currently highlighted. That's good. X list is L1. Y list is L2. That's where it's saying it's getting our X and Y variables from. That's good. Okay, so now that we've got all of that handled here, notice that's all of our steps there, right? It says we can hit graph. Okay, let's hit graph. Let's see what happens. I don't see anything. Do you? Did we go to stat plot? It's on. List 1 and list 2. Graph. Oh, wait a minute. We're not seeing anything here because remember this is a standard window, right? This doesn't allow us to see anything. And look at our x and y values here, our h and c values. They're big, right? 25 and 16. Those are way outside of our window. So if you hit the zoom button right here, zoom, and then you go down. I know we haven't gone down in this list very much before, but keep going down. Oh, number 9. Look at what number 9 says. Number 9 is zoom stat. If you select number 9, it's going to give you the best window to look at your scatter plot in. So select option 9 and hit enter. Ooh, that's nice. right? So now it's kind of hard to see what is going on here in terms of like the x, y, or h and c axes here, right? But this is our scatter plot. This looks kind of like what we had before in that baseball example, right? Okay, so this is our data here. Does it look linear? Does it kind of look linear? Well, notice that it kind of goes lower left to upper right. There may be some little extra weird point going on here or something like that, right? But notice in general it kind of goes lower left to upper right. Okay, so that's handling part A of this problem right here. Now in part B it says use a graphing utility to find a line of best fit. Well, finding a line of best fit just means figure out a linear model, right? Figure out a slope and a y-intercept which fits this data the best. The line which gets as close as possible to hitting as many of those dots as you can, right? And if you can't hit as many of them as you can, maybe get as close to all of them as possible, right? And that's what we call a line of best fit. And actually our instructions here allow us to do that as well, because notice in step 2 it says find the equation of the function of best fit. Well, for us it's a line for right now. Your calculator has the ability to model other kinds of crazy functions too, but we can find the line of best fit. So let's work through these steps here to find the line of best fit. Okay, so let's see, these first steps actually are repetitive here because it says stat key, edit, and it says type in x and y values. So actually steps 14 through 17 we've actually already done because we already have our data in the calculator, right? So we can skip to step 18 right here and hit the stat key. Okay, so let's hit stat. Where's our stat key? Oh, right here. Yes, underneath delete stat. And now it says go over to calc. Right? Okay, so calc is this menu over here. We need to arrow over to get to arrow over. Okay, so now we're in here in the calc menu. And then it says the function of interest. Well, so far, the only thing we are trying to model is linear models, right? So that's number 4. It says linreg. That's short for linear regression. Okay, fancy. But notice it's ax plus b. Kind of looks like a line equation. So let's go down to 4 and hit enter. Okay, and this is now sitting in your home screen waiting for you to do something, and you just want to hit enter so that it returns information. So this tells us that the line of best fit would be the line where a and b are some numbers, but notice a and b, those are the placeholders for slope and y-intercept. Okay, so if our slope was 0.3733840,304 and our y-intercept was 7.326806,084, that would be the line that best fits. Okay, yeah, so that's kind of useful with lots of decimals like that, but wouldn't it be more useful to either write the equation with those numbers plugged in or graph it? Okay, so let's see, let's move this over here for just a second so I can copy down what the line looks like. So this would be y equals, slope is 0.373, how many decimals should I go? How about 4? That looks good. X plus b is 7.32, how about 68? Good. This is our equation of line of best fit. Okay, and if we didn't want to call it y equals, and if we wanted to be specific in terms of this problem we're working with, I would change the x and the y to the proper letters, right? Because we don't have x's and y's in this problem, we have what? H's and c's, right? Remember, y is like our c, so that's c. Circumference is equal to slope times h, which was, what was that? Height, right? C was circumference, H was height. Okay, so this is actually our line of best fit where C and H are the proper letters, right? Okay, so this is all well and good, but it would be really nice to see this equation on the graph with the scatter plot. And it turns out we can do that as well, right? So with our calculator here, this is step 3, graphing our scatter plot and the function, the line of best fit on the same screen, right? So let's see, let's get our calculator back here. So let's go back to the stat key, so stat, and then we go over to calc again, over to calc. We go down to linreg, right, linear regression. We want to write or get our line of best fit, so hit enter. This time, hit enter one time to take it back to your home screen, but do not hit enter right now. Do not, because it'll give you just the information about the line of best fit again, and that's not what I want to do. I want to tell this thing to graph this line, whatever it is. So what I want to do is remember that we have the ability to store like something into like y equals or something like that. We can write an equation in y equals and it'll produce a graph for us, right? Well, I don't want to type all of this into y equals. That would be a pain, right? So what we can do is tell this to put it in like y1 in our y equals menu, right? So we do that by following our instructions and saying hit the vars and then y vars. This is variables, right? So hit vars right here next to clear. And then it says go over to y vars, so hit over. And now we want to pick a function, right? Like y1. Okay, so hit enter and select y1, number 1, hit enter. Okay, when you have this on your screen, okay, again you hit vars, then y vars, and then enter 1 for function, and then select y1 by hitting enter. It's now here, it's sitting there waiting for you to say yes, store that in y1. And it looks like it didn't do anything, but now hit y equals. In y equals, we have this crazy linear equation, 0.373840. Ooh, there's actually more decimals. X plus 7.3268 more decimals, right? So that's our line of best fit. Now hit graph. Ooh, that's nice. And look, that's the line that's sort of closest to all of those dots, all those points, right? Okay, so that's our line of best fit, and that's how we find the line of best fit. And this is approximately the equation of the line of best fit, right? So we'll pause here in terms of our example, and we'll continue with this kind of an example when we're in class together here, working out parts C, D, and E, because I know we're pushing the limit for the, the time length here for our videos. You're probably dying, right? Okay, so try that out again on your own, working through the examples. I've posted the instructions for the calculator to Moodle, so you can access those now or get a paper copy from me in class, and we'll work out parts C, D, and E together in class.